All right, so in this video, it's going to be the second part of the complex numbers. And what I want to focus on is multiplying them, rationalizing them, and then actually using them to solve. And so if we look at part E, and this time I'm going to zoom in, all right, we have what looks like a normal binomial problem. You got a binomial times a binomial. Whatever method you know to multiply this out, multiply it out. If you do distributive property, you do a little box for multiplication, you know FOIL, whatever it is, multiply it out. All right, so I'm going to do distributive property. So 2 times 3 is 6. 2 times negative 4i would be negative 8i. 3i times 3 is plus 9i. 3i times negative 4i is negative 12i squared. I responds just like any variable, even though it represents a specific number. So let's clean this up and do a couple things. So thing one, I know that these two middle terms would add up to just be 1i. Thing two, I know that I squared is really negative 1. So what I've got here is 6 plus I plus 12 when I multiply those together, so 18 plus I. Mathematical convention says to put the number first and the I term at the end. So please follow convention. All right, I'm going to go ahead and scroll over to number F here. Letter F, number F, sure, go with that. Letter F. Let's see, you've got 3 plus 2i squared, which means you've got 3 plus 2i times itself. Do the same exact multiplication. So 3 times 3 is 9. 3 times 2i, so plus 6i, plus another 6i, plus 4i squared. Okay. Now, if you can, in your head, translate this to just a regular number, that's awesome. What it would be, you'd have 4 times negative 1. I squared is negative 1, so that's really negative 4. So 9 minus 4 is 5 plus 12i. If you're not such a huge fan of that, and you did steps here that you're not following, feel free to add in the extra work here. And I'm saying extra work, but it's what you need, okay? So don't feel weird about it. So 9 plus 6i and 6i is 12i plus 4 times negative 1, and then you could multiply it out from there, or combine it out from there. All right, letter G here. Now, letter G looks like maybe when you first glance at it, it's like, oh, it's done. There's nothing else you can do there. Unfortunately, we have an I in the denominator. I in the denominator represents a square root, and we're not such a big fan of having square roots in the denominator. So what we want to do is be able to multiply this times something in order to get the denominator to be just a normal integer value. And so what you're going to do is you're going to multiply by something called the conjugate. Okay? And the conjugate is not what I just wrote down, so hold on one second. The conjugate is whatever you have in the denominator, in this case 2 plus 4i, you want to multiply it by 2 minus 4i. The middle sign is what will change, go the opposite. What you do to the denominator, you need to do to the numerator. Okay, so that multiplication work that we just did is what we're going to continue doing here. But make sure you focus on just the numerator times numerator and then do the denominator times denominator. So let's do some multiplication here in the numerator. So 8 minus 16i minus 2i plus 4i squared. Okay, all over, multiply out the denominator. So let's see, 4 minus 8i plus 8i minus 16i squared. Okay. For those of you playing at home, you may have noticed that in the denominator we have negative 8i plus 8i. Wave bye-bye. They're gone. Okay? So that's part of the reason why we do the conjugate, is because those two terms will cancel. Let's do a little clarification here in the numerator. So this term here positive 4i squared really means negative 4, okay? Because remember, this would be 4 times negative 1, so it's negative 4. 8 plus negative 4 is just 4, and then minus 18i all over. I'm going to kind of apply the same logic in the denominator. This term right here that has the I squared is negative 16i squared. So negative 16 times negative 1 is positive 16. So 4 plus 16 makes 20. And if we notice, right now we're at a position where there's no more square root in the denominator. There's no more I value there, which is what we wanted. There is one last piece to do, one little baby step here. You've got 4, you've got 18, and you've got 20. All three of these can be divided by a common factor of 2. So I'm going to go ahead and divide that 2 out. So 2 minus 9i over 10 is your new and improved fraction. Okay? We're going to do the exact same thing with part H. We want to, again, multiply by the conjugate of whatever is in the denominator. So the denominator right now is 6 minus 2i. So the conjugate of that would be 6 plus 2i. What you do to the denominator, you're going to do to the numerator. All right, numerator is pretty straightforward on the distributive properties. So let's see, 3, I don't know why I'm writing 3 down when I'm supposed to be writing 18 down. 18 plus 6i. All right, let's see if I get the bottom right in one try. No guarantees. All right, 6 times 6 is 36, plus 12i minus 12i minus 4i squared. Okay. So we cleaned up the numerator. There's nothing else to do here. Now in this denominator, again, those of you paying attention, which is hopefully, all of you for watching the video, will notice that the 12i and the minus 12i cancel out. They're gone. This term sitting here at the end, all right, the minus 4i squared, well, I squared is negative 1, so negative 4 times negative 1 is 4. So if we multiply, or not multiply, if we combine some like terms here, that should turn into 40. Again, I want to look to see if 18, 6, and 40 are all divisible by something. They are all divisible by a common factor of 2. That won't always happen, but if it does, definitely divide it out. It's like simplifying any other fraction. All right, so that's how you deal with the conjugates. All right, I'm going to go ahead and do, I think it's I and J next, which is actually solving. So problem I, my first thought is always when I look at this to say, oh, let me see if I can factor. And it looks like the numbers would be nice. What multiplies to 3 and adds to 2? And if you're drawing the same blank I am, that means that you can't factor. There is nothing that's going to multiply to 3 and add up to 2, not when both of them are positive. So if we can't factor it, we are going to throw this thing at the quadratic formula. So in order to throw it at the quadratic formula, I need to know what A is, what B is, and what C is. So A is 1, B is 2, C is 3. And the quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. One common issue that I'm seeing is for some reason this fraction bar is not being extended the entirety of the quadratic formula. This whole thing is one numerator. And this thing is one denominator, so please make sure the fraction bar extends. All right, so x is equal to negative 2 plus or minus. I am going to take this whole thing and whip it into my calculator and see what I get. So if I do, let's see, 2 squared minus 4 times 1 times 3, I'm going to get negative 8. All over 2 times 1 is 2. All right. So off to the side here, I want to do a little simplification for square root of negative 8. So I'm going to bring out the negative 1. And then the 8, I'm going to break it up into root 4 times root 2. So things that are going to happen here. This is the perfect square. So let me go ahead and pull that perfect square as 2, root 2, and then the square root of -1 is I. So little substitution here for the square root of -8. So plus or minus is going to be 2 root 2i all over 2. There's a lot of 2's in this answer. So I want to see if I can cancel some of these out or divide them out. I can definitely take -2 and divide by 2, and I can take 2 root 2 divided by 2. So that's what I'm going to do to finish this one out. So -2 divided by 2 is -1, plus or minus. Now, 2 root 2 divided by 2 is 1 root 2, or just root 2, and then the I at the end. Okay? So that's actually 2 answers for that problem because the plus minus, I'm letting you be completely lazy in this case and just write it as a single answer representing 2. Okay? One more problem here, and this is problem part J here. We have a 4-term polynomial that represents a cubic function, so we're going to be looking for possibly 3 answers. We're going to do this with called factor by grouping. Right? So if I group the first 2 and I look for a GCF, the GCF is x squared, and what's left is x plus 1. If I look at the second 2, they have a positive 3 in common, and what's left is x plus 1. Factor by grouping, you are going to know you're heading in the right direction when this parentheses and this parentheses match. Now, not that they're close, they need to match perfectly, and in this case they do. So we're going to go ahead and factor out that common term of x plus 1, and what's left then is x squared from their first parenthesis set right here, and then you have a plus 3 left over as well. Okay, so we're done with our factoring, but now that it's in factored form, we can take each of these 2 factors and set them equal to 0. Now, this one on the left, pretty straightforward, right? X is equal to -1, and awesome. The one on the right, let's go ahead and start breaking this one up. Okay, so x squared is equal to -3. I'm going to take the square root of both sides, and this is why this is in the imaginary section. So x is equal to, now, you just saw me put a square root in the problem, means I have to put a plus minus in place to accommodate both the positive and negative possibilities. And I am going to break that negative out of the square root, and so what I'm going to have here is root 3i. So you really do have 3 answers here. You have -1 is 1 answer, 1 root. You have positive root 3i, and then you have negative root 3i. So 3 possible answers there for that particular cubic function. All right, that concludes the second complex number video. If you have any questions on multiplying or using the conjugates or solving, send me a message, and I hope this has clarified a few things with complex numbers.